Okay, so let's get started with Cisco ACI. So first of all, we are going to discuss about the reasons why we should adapt the ACI. One of the reason is applications. Instead of having applications on the physical server, now we are having virtual services as a running as application. So one single physical server enough capable to run multiple virtual services on its backend. So instead of having physical infrastructure, now we are more to moving towards managing virtual infrastructure. Virtual services are more in quantity compared to physical services, and the cloud adoption is very common nowadays. Second is your choice of hypervisor. So earlier we used to have very limited number of hypervisor areas. Now we are having number of hypervisors available. We can use Hyper-V, we can use VMware hypervisor, we can use Kubernetes. We have number of hypervisor which can run different number of services. So instead of installing your application, your services on the server, now we are having number of hypervisor which you can have on your server, and that hypervisor can contain multiple services. So instead of having multiple physical servers, we will prefer to have the one physical server and running a hypervisor on top of it, and then we'll add the application and services onto the hypervisor. The reason for Cisco ACI, the cloud adoption, private versus the public cloud. Now, most of the organizations and business, I'm going in detail of private and public cloud later in the slides. So, the first of all, the most of the organizations and business nowadays are moving towards the cloud adoption. The reason, just take an example, a organization who is having 4 to 5 servers and they need to provide the access of those servers to their users. So instead of setting up the complete infrastructure just to provide the access of those 5 servers, when I say complete infrastructure, I'm referring the physical servers, then the network infrastructure to provide connectivity to those servers. Then we need to have security infrastructure, firewall, IPS, IDS, everything there in place to provide security to the servers. So instead of managing this complete infrastructure just to provide 4 to 5 services to the users, it's better to move those 4 to 5 services towards the cloud. Now users can access those services on the cloud through your WAN instead of having complete in-house infrastructure for a small number of services. When we come to big infrastructure, still we have provision of the cloud as well as in-house data center. So we are going to discuss about the cloud adoption later in detail on the slides. So what we need, we understood that this is the requirement which we need to cover nowadays. Now the question is what we need for it, what type of solution we need for this particular type of environment. So we need a solution which is well known as software defined network. Software defined network, again, as I mentioned, it's a very vast thing to cover up. Okay, and ACI is one of the part of this particular vast solution, which is software defined network. Now, what exactly this software defined network is? It's a very confusing thing. Maybe about a cloud, if you ask 10 people, you may get 10 different definitions about the cloud. But if you ask 100 people about SDN, you will get 100 different definitions for it, 100 different meanings of SDN, because each and everyone is having their own conception. They have their own thinking about the SDN solution, because SDN solution is not just limited to a particular technology, it is not limited to a particular vendor. Each and every vendor have their own SDN solution which provide different type of capabilities. VMware, they have the NSX, Cisco is having the ACI, Cisco is having SDA, SD-WAN, Nokia is having Nuage. So they all are having different SDN solutions, and they have their different methodologies. They have different terminologies. They have different how actually it provides the connective. solution to your application. So, meaning of SDN may differ based on their vendor and their solution, but what we are achieving at the end of the day, we don't bother about what does this mean. We bothers about what we are achieving at the end of the day. A solution mean to be a solution only when it helps someone to adapt its services. So everyone is having their own idea, everyone is having their own solution, but at the end, if that solution is not capable to solve someone's problem, that solution is irrelevant. So instead of understanding the different meanings of SDN, we need to understand that how this particular solution is meant to solve the problem of someone's. So first thing is application level segmentation and visibility. In the traditional network or in the traditional data center, we were very much limited to the application level segmentation. Sorry, the network level segmentation. The network level segmentation refers to the VLAN, refers to the network ID, network segment. I'll come to that later on. But now we need application level segmentation. I need application level visibility into my data center. Data center network has to know which type of applications are running in my data center, how my users are using those applications, what are the needs of from the network to those applications. That is something till now a human control thing. Now we want that application should control themselves the requirement from the network. Second is network configuration automation. We need the automation to configure our network. So what all things we configure usually in our network? So if I take an example, we'll do some quality of service policies. We have some security, like for an example, I'm just thinking a traditional network. So we have ACLs to provide security. Then we have some load balancing mechanisms configured, and so on. We have number of different type of policies. Now I have 500 boxes in my network, and I need to go in each and every individual box and configure same set of policies. Where what's my ultimate goal? My ultimate goal, that application should have the limit from the quality of service, should have security from the my ACLs, and should have the load balancing mechanisms. So that's my ultimate goal is. But I'm going to repeat the same story again and again in 500 boxes. Am I making sense? So this is how my traditional network was. Okay, just a second. Where I need to log in individually in all those 500 boxes and configure same set of policies. I don't want to do the same thing again. I don't want to do this thing anymore. So what I need a network automation. Okay, network configuration automation. Application integration. So when I'm saying that I have application level visibility, I have network automation, so let the network intelligent enough so that it can understand the language of my applications. It can understand how my application speaking. Earlier, we used to have two different silos. One is network, where we talk ACLs, VLANs, networks, all these things. Other one is application, where we'll talk about Dockers, containers, different Python, different languages, JSON, XML, different languages, and all this. So these are two different silos. Now we want them to merge. We want that what application is saying network should understand, what network is saying that application should understand. So what we need for this, we need the integration. We need the integration between the application and the network, so that whatever network is saying can be understandable by the application, and whatever application's requirement is, network should understand. So when that integration is there in place, my job is going to get reduced. Now, instead of discussing with the application developer what type of application it is, what type of requirement does it require from the network, and all these things, now let application talk to the network. So now no more application developer need to explain me that what exactly the requirement required from the network, and I don't need to explain to my network that you should perform like this way with this set of configuration. So how application centric infrastructure ACI will help me to achieve this? It provides me network virtualization, open source, open APIs, open communities, single point of control and management, policies, and automation. So these all things I'm going to control from a single pane of glass, a single window, where I can do application level segmentation. I'll explain more in detail how. I can do the auto configuration automation. Now, if I have hundreds of boxes, thousands of boxes in my data center, I don't need to get into individual box and configure everything. I just from a single management solution, I'm going to push out the configuration, and my all the boxes will get configured. Then the last not the least, application integration. So ACI does provide me the application integration using my layer for layer 7 service integration. We have VMM domain integration and so on. We'll discuss more in detail once we get into the technicalities of ACI. So far we are at the introduction level. Now, what this application centric infrastructure consists of? Application centric infrastructure consists of, first of all, Nexus 9000 series switches. So far in the Cisco, they have only one series of switches which supports ACI, which is Nexus 9000. In Nexus 9000 we have 9300s, we have 9500s, and some are used as spine, some are used as leaves. So that is about the fabric architecture. I'm not going into it right now. Then second is your application policy infrastructure controller, which is known as APIC controller. APIC controller works in cluster of three controllers. Means it can work as one also, but if you want to create a cluster, I have a highly availability solution. Then you need three APIC controller. Why? We'll get into it when we talk about the technical stuffs related to it. And then the industry leading ecosystem it consists. So what do I mean by industry leading ecosystem? It has the integration with most of the vendors available in the market. It's not a Cisco itself a solution. It is a vendor neutral solution. You have Red Hat, you have VMware, you have Citrix, you have Python, you have IBM. Everyone can get integrated to ACI. So it have an open API. Using that, we can integrate any of these solutions directly to the with the ACI. Now, earlier we used to have a two different isolated infrastructure. I was for which I was talking about. In network, we have VLAN, subnets, bridging, routing, IP addresses, HSRP, VRRP, VRF. These are the things in the network point of thing. Then in the application side, we have component services, zones, life cycles, big data, containers, cloud. All these things are the application. What ACI is giving me here? ACI is providing me an interface which helps me to integrate two different infrastructures together. So I will convert my network components in a way that the application component can they can understand. Sorry. So this is how the ACI is going to provide a neutral infrastructure where one network can talk to it, and as well as at the same time application can talk to it. What were my traditional network approach? My traditional network approach refers to the, in my traditional network, the segmentation was based on the either layer 2, which is VLAN or MAC, or layer 3. So how will you segment? So just take an example. You have a data center, you have a web server, you have app server, you have database server, you have some third party servers. How will you segment them? What is the first thing which strikes in your mind when you think about this segmentation? Is VLAN, IP subnets? Let's create a VLAN for web services and assign one IP subnet. Let's create one VLAN for app servers and assign one VLAN. That was our traditional approach. So one VLAN, one VLAN is equal to one network segment. This does not mean a VLAN cannot have more than one network segment, but VLAN is a broadcast domain. Broadcast domain refers to one broadcast boundary, which is actually one network. So one VLAN, one network. VLAN 20, network is 10.1.1.0. Similarly, we have VLAN 30, VLAN 40, and each one is having their own subnets. And one VLAN refer to one set of services. So this maybe refers to my web service, my web services. So this was the traditional segmentation approach. One VLAN, one network. One VLAN, one network. All the policies like quality of service, security, segmentation must be configured on the first layer 3 hop, which is a gateway device. It can be a core switch or a router. So all the servers needs to go to the router first, then they will get their policy like QoS marking, some security ACLs and all these things, and based on it, it basically segregates. So this is how the thing is. But now, will it help me in case of, just take an example that there is a company acquisition. I'm acquiring one company. Now that company having different set of IP addresses, I don't want to touch it. Okay. So I just wanted to keep the same policies they were having at the initial stage, and they were there. Now later on, I want a single network. I want the everything should be in the my network range, my IP planning. IPs got changed. What happened to my policies? All policies, either it's a quality of service, it's a security, anything related to my servers will be obsoleted, useless. Why? Because on what basis I have created those policies? I have created those policies based on the IP network, based on the VLAN. Now, if my IP network or VLANs are getting changed, my policies are useless. Now I need to create them again from scratch. So, my dependency, where is my dependency here? My dependency is completely on IP subnet. The what is the IP address configured on the server? My complete dependency is on it. What VLAN they are using, my complete dependency is on them. So how can I be more smart? It was working from decades, I agree. But now we want more advanced, more smart solution, so that we remove our dependencies from the IP, from the network segment, from the VLANs, and move straight to the application level. So why not I say web server? Why I'm saying web VLAN? Why I'm not referring web server 1, web server 2 instead of referring 10.1.1, 10.1.1.2, 10.1.1.3 like that way? Why there are differentiation between the application terminologies and the network terminologies? So to remove that gap, to remove that particular gap between the network terminologies and the application terminologies, ACI will help you. So the traditional approach was one VLAN, one network segment. So we may have a one web VLAN, one app VLAN, one database VLAN, and they are three different subnets, and all the policies based on that servers. So for an example, web is having 10 subnet. I'm just referring. App is having subnet 20. Database is having server subnet 30. I want web should talk to app. I want to create a policy that web can talk to app. What type of policy I'm going to create? I'm going to say that 10 can talk to 20. This is the policy which I'm going to create. Can I create a policy saying that web can talk to app irrespective of their IP subnet? No, that is not possible. That is not possible in my traditional network approach. My complete dependency is on this side of things. It actually the network devices don't care about what is web, what is app, what is database. They just care about okay, 10 subnet, 20 subnet, 30 subnet. If you want to create any policy which is saying that who should communicate to whom, who should communicate to whom, you need to have this network details. That's all. So that was my traditional approach where my complete dependency is on this side of thing. I want to create a dependency on this side of thing. So that whatever network is tomorrow, some other administrator has come in and he just changed the my IP planning scheme. So my policy should not affect because of it. That's the main reason. So my ACI provides me that interface that I can move my dependencies from here to here. How? We'll talk in detail. Now, what are the different terminologies we are having in ACI? First of all, we have tenant. Tenant is the uppermost, I can say, tree or we can say root of the ACI. So we need to create one tenant. So it's like a hierarchy. It's the topmost branch of your hierarchy. Okay. So let me just draw it up. So first of all, we have tenant. So tenant is the topmost root of your hierarchy, or we can say it's a root. Then it can have VRF. It can have multiple VRFs. VRF, I guess you guys are more aware of. It's a virtual routing and forwarding. If not, don't worry. We'll get in detail about this as well later. So one tenant, we usually create one VRF in, but we can have multiple VRF in a tenant. Then inside of VRF, we are having bridge domains. One VRF can have multiple bridge domains. So bridge domain, not completely, but you can refer bridge domain is like a VLAN. Bridge domains are like a VLAN. It's a individual boundary of the endpoints. So they can have different VRFs, can have different BD, bridge domain. Now inside of bridge domain, we are having EPGs. We can have multiple EPG endpoint group. It's a group of endpoints in one BD. Okay. So this is your EPG. Now then further on, EPG consists of EP. EP is your endpoint. It's actual server user whatever device you have connected it. So they are actually EPs. So one EPG can have multiple EPs, can have multiple endpoints. So this is how the hierarchy looks like. Now, within the BD, EPG can talk to EPG. Okay, you don't need anything for that. But when we talk about between BD, if one BD wants to talk to other BD, we need a contract. Contract is nothing much, is like a ACL. Okay, so you need a contract between BD to BD communication, and within a BD, EPG can talk to EPG without any contract. Now then you have a in contract, when we refers to the term contract, we have a provider consumer relationship. What exactly this provider consumer relationship in the contract? So you have, let's say you have a BD of web servers, all the web server in one BD. Then you have a BD for all database server, and then you have one BD for all app server. So they need to have a contract between them, so they need to do a provider consumer relationship. So let me change my color. Web server can be a provider to the database, and database will be the consumer for web server. So don't think much on this part. Okay, we are going to discuss much more in detail when we talk about, when we do the demo of the contract, that how the provider and consumer relationship looks like. So one BD will be a provider to the other BD, and that BD will be consumer for that, from that BD. Okay, and then the last and most important is fabric. What exactly the fabric is? Fabric is actually consist of two things. So fabric is actually combination of spines and leaves. So you have spine, which is known as a back plane, and then you have leaves, which are known as forwarding plane. So forwarding plane means you actually connect your servers and all to those leaves. And you have connectivity like this, a redundant panel. A leaf cannot get connected to other leaf directly. A spine cannot connect to other spine. It's basically limitation with the clause topology. This is called a clause topology design. So this refers as a spine and leaf architecture. We are going to discuss about this in detail, how the spine and leaf architecture build up, what are the things in the back end. But these are the forwarding plane, your leaves, your actual servers are getting connected here. You have your actual servers. So for an example, if my server 1 wants to talk to server 2, so traffic will go and come hit to leaf will have a equal cost 2 path. It's complete L3. This is complete your L3 routable network. So they will send a traffic based on the ECMP. It will load share between both the leaves, and then it will come to this via this way and reach to the server. So you will have a complete load balanced fabric, load balancing enabled fabric. At how, what all protocols will use, basically we'll use ISIS for the info only, and we are going to discuss much more in detail about the fabric architecture later on the slides. Transition to ACI. So traditionally, do I need to buy a complete new infrastructure when I'm going to implement ACI? No. If you are already having Nexus 9Ks, 9500 and 9300 already in place, you just need to add a Epic controller and you change your OS mode. So Nexus 9000 runs in two mode. One is your standalone NXOS mode and one is your ACI mode. So you need to change your operating system mode from standalone NXOS to the ACI mode, and you need to add your Epic controller. That's all. You are going to have the ACI infrastructure. You don't need to buy everything new. If you already have 9500, 9300 in place, just upgrade the iOS, just change the mode of the operating system from standalone NXOS mode to ACI mode. Okay, and when you go to ACI mode, there is no traditional CLI like show, run, conft, all these things will not work. So you need to get rid of all these things and discuss about the detail. No, we cannot have both. You either your device can run in NXOS mode or it can run in ACI mode. Once you change to ACI mode, then it's complete ACI only. Then no more conft, no more show run. You have end number of show commands, but not like traditional NXOS. It's more on the ACI related commands. How the ACI segmentation looks like, you can see I have three EPG, EPG1, EPG2, EPG3. EPG, as I mentioned, it's endpoint group. So I have EP1, EP2, EP3, EP4 in all three EPGs. Now, on what basis did I did this segmentation? Is it again the IP address? No. They can be in the different subnet, they can be in the same segment, same network, EPG, maybe some in zone 1, some in zone 2, they have different network. So it can be possible either way around. Okay, you don't need to have the EPGs, the same network EPG endpoints in one EPG. So like all web server, it may relate to same network, it may relate to different network, all are going to be part in EPG1. Now I will create a policy that EPG1 can talk to EPG2 instead of creating the network way. So irrespective of the network segment, everything is going to be based on my application characteristics, server characteristics, service characteristics. How? We'll do the demo for it. Now, how the contract plays role? Contract is basically a communication, a provider consumer communication between the EPGs. You have your contract between your EPG that they can talk, they cannot talk, who can talk, using what all things, what I can define in my contract. They can talk to ECP using ECP port, TCP port 80. They can talk to TCP port 443. They can use service chaining. We have a number of things to define for. So this is, guys, moreover the high level architecture of the ACI and what all things we are going to learn in this particular solution. So we are going to have an in-depth discussion on each and every topic which we have discussed here. It's a high level architecture only. Maybe I'll see you in the next session and we'll have much more detailed.